All right, so homework 37, we're starting out converting rectangular coordinates to polar coordinates. And on our polar coordinates, you want to have the magnitude of your vector, or the radius, and then you want to have the angle of your two lines that's in there. Again, just to remind you, you are going to need this sheet here where you can look up your inverse tangents like we've done before. And so you want to make sure you have that sheet handy. If you don't have that sheet handy, find it. We just used it on the previous homework page. So going back over here, in polar coordinates, our polar coordinates are going to be r, which is going to be the size of your line, and an angle. So if I draw my rectangular coordinates, x is -4, y is -4 square root of 3. So I'm down here in quadrant 3. I want to find the r value. In other words, I'm finding the size of that line using my Pythagorean theorem. R is equal to the square root of a squared plus b squared. So I'm going to have the square root of -4 squared plus -4 square root of 3 squared. So -4 squared we know is 16. -4 square root of 3. If I take -4 square root of 3 times the second -4 square root of 3, I get a positive 16 square root of 9. So that makes that 16 times 3, which gives me 48. 16 plus 48 is 64. So I have the square root of 64, which is just 8. So my polar coordinate, the first value is going to be the 8. I would go 8 to the right. Now I need to find the angle that I have to go around. So for my angle, again thinking of this angle here, I have to do the tangent. So I am going to do the inverse tangent of the opposite over the adjacent. So -4 square root of 3 over -4. -4 square root of 3 over -4. Those cancel out, so I'm doing the inverse tangent of the square root of 3. Now I can see over here that I'm in quadrant 3. So looking at my paper for the angle, for quadrant 3, inverse tangent of square root of 3 is 240 degrees. So 240 degrees is going to be my other measurement. And so -4 and -4 square root of 3 in polar coordinates would be 8 and 240 degrees. So number 2, my rectangular coordinates are at -3 square root of 3 and +3. So this time I'm over here in quadrant 2. R is the square root of -3 square root of 3 squared plus 3 squared. So if I take -3 square root of 3 times the second -3 square root of 3, I get positive 9 square root of 9. Square root of 9 is 3. 9 times 3, 27. I get 27 when I square that. 3 squared is 9. So 27 plus 9 gives me the square root of 36, which is just 6. So in my polar coordinates, my first value is going to be a 6. I then need to find my angle. Using my inverse tangent, my opposite over my adjacent. So 3 over -3 square root of 3 would reduce down. I'd have 1 over square root of 3 if I rationalize that. Square root of 3, square root of 3. I get inverse tangent of, this is going to be negative, square root of 3 over 3 then, right? Have the square root of 3 over the square root of 9, which makes it square root of 3 over 3. I am in quadrant 2. So in quadrant 2, I'm looking for inverse tangent of negative square root of 3 over 3. So if I look there, I have 150 degrees if I look at my table. So my polar coordinates would be 6 with 150 degrees. Number 3. My rectangular coordinates, I would be doing the square root of 3, which is positive, minus 1, which is negative, so I'm going to be down there in quadrant 4. R is going to equal the square root of 3 squared plus negative 1 squared. This would give me the square root of 9, which is 3. This would be 1. 3 plus 1 is 4. The square root of 4 is 2. So in my polar coordinate, 2 is going to be my first value. My angle, I am going to do the inverse tangent of the opposite over the adjacent. So negative 1 over the square root of 3. Again, I have to rationalize my denominator. So I'm going to have the inverse tangent of negative square root of 3 over 3. This time I'm over here in quadrant 4. So looking in quadrant 4, inverse tangent of negative square root of 3 over 3 is 330 degrees. So this is 330 degrees. So my polar coordinate would be 2 and 330 degrees.